Okay, welcome back, and let's continue. So now I was talking about immediate values. So it turns out you don't have to specify immediates as literals. You can use a symbol for an immediate. And you may have seen something called a label, right? Uh, in assembly. In C, you can have labels too, even though most instructors probably say, no, don't use labels because that's for GoTo, and GoTo programming is a bad idea. But, well, in assembly, you have no choice but to use labels. Label is a name colon, right? It marks a location. And it turns out you can use a label or the value of a label as an immediate as well. So here, for example, you have some assembly listing, some instructions, and then some label, right? It could be any identifier, colon, right? That's a symbolic name for that address. And then you can do DB and some string hello world. That's for defined bytes. So that just puts the ASCII code for H, E, L, L, O individual, right, as a sequence of bytes. So that marks that location. And if you want to say, okay, I want the pointer or the address of the location marked by label, you could. You just do move dptr pound sign label. And the assembler, as you probably know, makes two passes. First pass, it figures out all the locations of the label. Second pass fills in the labels back in the instruction, right? So that's the second pass is where it replaces pound sign label with the actual address of that memory location. Okay, so you can use label in your immediate as well. And this will fit the size of what's expected for DPTR, 16 bits. Now, direct addressing means that you specifying the direct address of the operand. That's residing in the iData, or sometimes called on-chip memory. And that includes also your general purpose I/O ports, special function registers, and all that. Now, you use direct addressing to name anything within the space. And so special function registers include the processor status word PSW, stack pointer, ports, DPL, DPH, and all that. Now, when you name this, it's part of the instruction. So that means you're specifying a fixed address with that instruction. And that cannot be moved or changed at runtime. Now, register versus immediate versus direct addressing, right? So, I mean, the syntax looks very similar, but in terms of binary, they look very different, right? So, if it's register, the R0 is part of the last 3 bits. If it's immediate, it's an entirely separate byte. If it's direct address, it's also an entirely separate byte of all zeros. Okay, so even though they're different by only one letter, right? One is an R, one's a pound sign, one has no extra character. Still, their assembly or their assembly is different only by one character, but the binary look entirely different. Okay. And right, so subtle difference between register direct mode, right? Direct mode 2 bytes for this instruction. Register mode 1 byte. Okay, and now, so they could actually do exactly the same thing. Why? Because if your bank is selected to be 0, then R0 actually corresponds to memory on-chip memory address 0. So they will do exactly this. They'll have exactly the same effect if your bank selected is bank 0. But they actually can do different things if your bank is selected differently, and the memory size is different, or the code size is different. So here are some combinations allowed for move. Destination could be accumulator, register, or an at sign in front of a register or direct address. Now, source could be register or at a register if you have accumulator as the destination. So accumulator as destination, you have option of register, at register, immediate, or direct. If the destination is register, at register, then source could be A, immediate, direct, or if the destination is direct, then you have A, immediate, direct, register, or at register. But that's not the full combination. So some combinations are not allowed. So what are not allowed? Well, register, register, move. So you can't say move R1, comma R2. That's not allowed. And so what do? Well, you have to go through the accumulator. Now, accumulator to accumulator move, like move A, comma A. That's not allowed either. Why? It's useless. So A gets A. Why would you want to do that? Anything move like pound sign 23 or pound sign 20 comma something else. You can't override a constant. So that's nonsense, right? So some combinations are not allowed for good reasons. But you might say, hey, I really like the register to register move. You see that in RISC instruction set a lot. But sorry, for 8051, that's just a price you have to pay. So if you want to move from R2 to R1, you have to move R2 to A, then A to R1. You have to do it in 2 instructions. Okay, so that was just move, but the rest are actually more fun. Add instruction. So add has a format of A, comma source. What does that mean? That means A gets A plus source. Source could be again one of those. Could be you've seen could be immediate, could be register, could be direct address, and all that. Now there's actually another version of add called add C. C stands for carry. So as with most instruction set architecture, there's something called a carry bit, and it also goes by the name of C or CY. And there's a slight difference. I mean, they refer to the same thing, but the name difference I'll explain later. So that allows you to do. So at C is A plus the second source plus the carry bit. Now, what's carry bit? Well, if you're doing math, right, you add 2 digits. Like 3 plus 8 is 11. Well, you write 1 and then the carry of 1, right? In binary, you do the same thing. So if you're adding 2 bytes and there's a carry, well, that carry bit is saved in a bit register called C or CY. And add C, what that'll do is then take that saved carry bit and then add it back into the 2 numbers you're adding. Okay? So that's what add C does. Whereas add doesn't do the extra carry. Now, source can be immediate, direct, register, and I think maybe also a register indirect. We'll talk about that later. Yeah. So here is combinations allowed. So destination has to be A. Well, it's both a first source and destination, right? And source it could be register, indirect, immediate, direct, register. And you notice A cannot be on the right-hand side. Can only be on the left-hand side. And left-hand side can only be A. Cannot be another register. So you can't say add R1, comma A. That doesn't work. So it has to be A only. So that's a restriction on add and add C. And you might say, so why is that? Well, it's just the way that they design the instruction set for really tight encoding. Okay. So, okay, then let's do this. How do we do something like this? I want to do R2 gets hex 25 plus hex 34. How can I write code like that? So first step is I need to move the constant 25 hex into accumulator A. And then I can do add A comma and immediate, right, pound sign 34. So that means A gets 25 plus 34, right? Because 25 is already in A. So when I do add A comma 34 hex, that's A gets 25 plus 34. And then to put it into R2, well, I need to then do a move from A to R2. That's the way 8051 requires you to do it. Now, you might say, well, why couldn't I just do move R2 comma pound sign 25? Well, that part is allowed, yes. Now, if I do add R2 gets R2 plus pound sign 34, well, sorry, that's not allowed. Because, as you recall, the destination can only be A. I didn't make up this rule. Just that's the way 8051 requires you. Okay, so you must use A as the first operand. But the smarter way is to just say, oh, I know 25 plus 34, that's a constant expression. I do runtime constant folding, and so I compute. That's 59 hex. So I just do a move, R2 gets pound sign 59 hex. And so, yeah, consider that because that's actually the fastest way to do it.